and we are producing next generation femtosecond lasers for precision micromachining. We have our own invention, a gigahertz rate process in our lasers. And I want to talk today about this gigahertz rate operation, as well as a very interesting application in ophthalmology of our lasers. That's the intraocular lens processing. So femtosecond lasers are applied since 20 years in the industry. They have many different applications. It's really difficult to focus on one field because there are really different lasers good for very different applications. However, our focus is on precision manufacturing and specifically on medical devices, aerospace, and glass processing. However, there are really interesting applications also coming for the real future tech, such as photonic ICs and even quantum technology, as well as in healthcare and bioimaging and spectroscopy. Since our lasers use very low, very short, ultra short pulses, and they can have really low power, and they can interact with any molecules quite easily. So femtosecond lasers are really state-of-the-art tools for precision manufacturing. They use ultra short pulses, hundreds or tens of femtoseconds, so they don't heat the surface, heat the material that they are machining, and this helps to get a single process production, which means we don't heat, melt, or we don't deform the material that we are processing, or we don't leave any residues, or not any, but many residues, let's say, on the material. And it can machine all kinds of materials like diamond, very hard metals, polymers, ceramics, composites, whatever it is. So it really sublimates the material on the specific focus. So it can be really a good tool for innovators from all sectors or high-tech sectors. However, there are some drawbacks, mainly the speed. They are quite slow compared to nanosecond lasers or mechanical processes, and the efforts to speed up the lasers increases cost and the industrial adaptability feasibility goes down. So this is our invention, the cool burst technology. The efforts to speed up femtosecond lasers use high energy pulses, but when we increase the energy of pulses, we lose some advantages of femtosecond lasers, and we start to heat the material. And instead of that, we have tried another method. We use low energy pulses at gigahertz frequency. That's the frequency where the material relaxes during the process. So it's really in a deep physics phenomena of machining. So this way, by sending gigahertz frequency bursts, we could machine materials up to 15 times faster, which is really very important for industry, actually. And Lumos Laser has started with this goal to commercialize this technology and build lasers with this technology. So we are really happy to bring this technology to life, to the market. We have made our first sales, and we have many projects going on. And I'm going to talk about one of the very interesting projects today. These are some of the applications. We also develop our lasers on the way. We have our technology roadmap continuously developing, because working in gigahertz region is a really big challenge. So, but until today, we managed to develop many applications such as medical black marking, glass drilling or coating removal over a tempered glass, which is very challenging, and medical lens processing and some other medical devices we are still working on with our partners. But we are the laser module developer, I have to mention. So coming to ophthalmology, we have a very interesting project with VSY Biotechnology and two universities for this development. VSY Biotechnology is also a Turkish company producing IOLs. They have both all monofocal, bifocal, or trifocal, even toric IOLs in the product range, and they use casting and traditional mechanical machining methods, and they reached to Lumos, and we have started a project like 3 years ago to machine the lenses with laser. What does it bring? It brings really a lot for the producers. Um, as also Francisco told some time ago, it's a really challenging process because we are dealing with a polymeric hydrogel, which is not a very stable material to handle. So at the moment, in the processing of optical part of the lens, we use a lot of molds because we have a lot of different patients. So customization has to take place, and it's quite important, obviously. And when we go to laser process, however, we just have one mold and we make almost all of the rest by laser. So this gives a lot of design freedom and a really good opportunity for customization. And the second advantage is in the cutting of the lens. So we just discussed the uh, optical part processing, and also we have to cut, and this cutting is also very challenging because it has to be a perfect lens with very sharp edges and like micron precision. In order to do that in mechanical cutting, there are a lot of different steps to like molding first and then cooling, cutting, and it's quite a big challenge because you have to fix the tiny lens on some surfaces. So there are some scraps, and operational efficiency goes down a little bit. And if you really can produce in high with a high operational efficiency, this is really very helpful for the future innovation. And this is what we try to do in this project. And also, laser is a digital production tool. So this is a movie. I will stay here for a while. Here we have transformed a monofocal IOL into a bifocal enhanced depth of focus lens. You can see that it's done in seconds, and no burrs, no cracks, no burnings, or no particles. So it was a very successful part. Then we started to develop the trifocal IOL with using Fresnel rings. This is a patented technology of VSY Biotechnology. And we made also our simulations and tried some first trials on glass. And after that, we also managed to produce. Here you see the trials on lens in our production system. And we have developed our process first according to the lens. And we can change this with respect to the lens design. So these are some results I want to show you. We really managed a clean process on micro scale. Of course, there is room for improvement. There will always be room for improvement, I guess, considering IOL processes. But for a research project, it's quite good progress for us. And we have also used the cleaning of the lenses after process, and we really got good clean surfaces, and biocompatibility and chemical tests are also all well done. So we are going for clinical studies, and here you can see the movie of the cutting process. I hope you can see the movies as good as I do. So on the right side, you can see some cut samples. Takes place really fast and also clean. However, I cannot show you every detail. It's still under investigation, but the cutting is also extremely important for the lens quality. So, as I said, we are a startup company. We are three PhDs and two masters. We are in Istanbul at Boğaziçi University and Özyeğin University. We use both facilities as well. We have more than 30 years of ultra-fast laser design experience and some industrial experience. And we are really looking forward to for R&D collaborations to discover more capabilities of our lasers in different fields. And so if you have any ideas coming to just presenting the technology, please contact us. And actually, that's all from my side. Thank you very much.